Let's say you have a pallet storage like this one here in a high bay storage rack with, for example, a forklift for operating the storage aisle and interchange positions for handing over pallets to and from the storage aisle. So this could be via an AGV or, for example, other forklifts. And you want to model it, you want to simulate it for example, assessing throughput capability or storage utilization. I developed a small template for that, a small framework in Python that you can use for it and that you can access on my blog. Here's another view of the assumed layout. So I'm assuming that we have a couple of storage aisles that are operated by either forklift or ASRS machine. In the default version, we will assume that there is always only one forklift or ASRS machine per storage aisle and that all storage aisles have the same length. I'm also assuming that there will be two interchanges per aisle. Here in this drawing, they are shown here at the end of each aisle, but they could be wherever in the aisle. So they could also be, for example, in the middle of the aisle. They could also be asymmetric. So one interchange position could be here at the end of the aisle, and the other one could be somewhere in the middle of the aisle. In the default version, there are only two interchange positions per aisle. And if you want to change these assumptions, you have to customize the framework that I provide in this product. Customization can either be done by yourself by editing the underlying Python code or by contacting me for support. Another critical assumption is that we will assume here that the interchanges to the aisle facilitated through either forklifts or AGVs always consist of delivering a pallet to the storage aisle and after that retrieving a pallet from the storage aisle. So the forklift that delivers a pallet to the storage aisle will, upon having delivered a pallet to the storage aisle, retrieve another pallet from the same storage aisle. So that could be, for example, an empty pallet or a pallet for another shipment. That is the assumption for this basic framework. And again, if you want to deviate from these cycle assumptions, then you have to edit the framework, which is basically a start point and a template for getting started and for building customizations into. Here's some parameters that you can adjust. So the framework that I provide in this Python product already supports configuration of a range of parameters, for example, the speed in the different directions of the forklift operating the storage aisle, as well as the acceleration and the handling times for handling a pallet in the compartment or at the interchange, the amount of aisles, the amount of columns per aisle, the width of a column, the number of tiers in a storage rack, and so on. You can see here all the parameters supported for configuration. So you can change the values of all of these parameters and analyze the outcome based on these changes. So you can conduct sensitivity analysis by adjusting these parameters. And again, here you can, for example, see that all columns have the same width and all compartments have the same height, so basically the same dimensions. Again, if you want to deviate from these underlying assumptions, then you have to customize the framework. And lastly, here's some KPIs that are supported. So the default framework provided in this downloadable Python package supports tracking of number of putaways and number of retrievals and number of moves per forklift operating the storage aisle, as well as the cycle time history of all the moves conducted by the forklift, and then the amount of busy and idle time per forklift operating the storage aisle. So this allows you to, for example, plot three basic statistics: a distribution of the cycle time of the forklift operating the pallet storage, the state distribution of the forklift, and also the throughput per aisle and per forklift or ASRS machine. So forklift or ASRS machine in terms of this simulation package, it's identical here. You can use it for modeling an automated storage aisle or a manually operated storage And here you can see the basic composition of this package. So we have a main Python file which basically implements the simulation model, so the application, you can say, the specific problem that we're implementing. And this specific implementation, implementing the specific problem that we want to model and analyze, consumes then, for example, a framework module. So one is the equipment Python module, which comprises, for example, a class for modeling the forklift operating the storage aisle. We have a job data module for modeling the jobs and tracking the data related to the jobs fulfilled by the forklift. There's another module for containing basically a class for modeling the storage aisle itself. And then there's also a configuration file where you can adjust all the parameters that I showed on one of the previous slides. The main file contains an example, so this is like a case study. And after this simulation is complete in the main file, the results are outputted in the plots file where you can see the plots being generated. So here you can, for example, see the throughput per aisle. So in this case there are 10 aisles, one ASRS machine in each aisle. And you can see here the number of putaways and retrievals that were done by the respective ASRS machine. And in the dashed line you can see the average throughput, the average total throughput of an ASRS machine. So the sum of putaways and retrievals on average per ASRS machine.